Do you ever feel a sense of wonder about the nature of the universe? Well, I do when I watch my cat play with their spring toys, because whenever I take them out, they end up under the couch again in 15 minutes. And as a researcher at the forefront of computer science and physics, I want to understand why. To a certain extent, we know why. The cat pushes them under the couch. But what I really want to know is, why do they end up under the couch so fast? Do they always end up under the couch this way? Is there something weird about my cat? To answer this question, I created a simulation. Here we can see an array of springs on the floor of a room. It's an empty room, there's nothing in it, and we see a cat, represented as a circle because, as we know, cats are perfect spheres, pushing the springs around at every time step. The cat will pick some position next to a spring where it can fit, and then it will push the spring forward, and then it continues. Let's increase the time step here. As we can see, the cat is pushing the springs all the way around the room, but they're not getting stuck anywhere, not in corners, not along walls, anything like that. Now let's see what happens if we introduce a couch into the room. All of a sudden, we can see that some springs are getting stuck under the couch. Under the simulation here, I've created a graph of the probability over time of any spring getting stuck. As the cat touches the spring more, the probability goes up, according to what appears to be an exponential distribution. If we wait for long enough, eventually, all of the springs end up under the couch. If you think about it, this kind of makes sense in a monkeys typing on typewriters producing the works of Shakespeare kind of way. If there's any region where the spring can go, but the cat can't, then eventually the springs, once they get there, will get stuck. And over the course of time, as more springs arrive, more of them will get stuck, until eventually all of them are stuck. So then our next research question is, why so fast? So far in this graph, we're only measuring probability according to how many times the cat has touched the spring. We don't know how quickly the cat touches the spring, though. This is where we move from computer science into the realm of experimental biology. We need an experiment. So I pulled out the couch, rescued a bunch of springs from underneath, and dumped them in the middle of the room to see how long it would take my cat to push them back under the couch. Pretty much immediately, a spring ended up back under the couch. Despite this promising start, we soon ran into a problem that plagues much of experimental biology. The subject was aware that she was being monitored, and this affected her behavior. Basically, my cat got distracted by the camera and stopped playing with the springs. However, in all of my footage, there were regions of being locked in where the cat was playing with the springs as intended. If we're trying to figure out how much time there is between touches, then we can simply focus on these locked-in regions and measure the time between touches within those regions. I hypothesized that the cat touching the spring would follow a Poisson process, where the time between touches follows an exponential distribution. I painstakingly measured a bunch of videos of my cat touching springs, measured the time between touches, put them in a graph, and sure enough, they do nicely follow an exponential distribution. After fitting the model, we found that our exponential parameter lambda is equal to 0.19. Now, the expected value of an exponential distribution is 1 over lambda, which gives us around 5.26 seconds between touches on average. Now, this is a bit of a problem. According to our simulated data, for a 75% probability that a spring is under the couch, we need 337 touches. At 5.26 seconds per touch, this means that it will take almost a half hour before a spring ends up under the couch. That's twice the expected time of 15 minutes for all the springs. The probability of 6 springs, which I should add is a small drop, there's normally 12 under there, all ending up under the couch in under 15 minutes is 1.4%. So what's going on here? At this point, I think it's time to take a cue from physics. Now, I'm not a physicist, I'm a computer scientist, but I think that gives me the ability to conjecture widely in this area. Pigeon. Here, pigeon. In the world of physics, we've had another scenario where our theoretical results don't match our actual measured results in experiment, and that's in the expansion of the universe. Due to mass or something, the universe is expanding either faster or slower or something like that than expected. In order to make the model match those results, we needed a lot more mass in the universe. So we simply invented a bunch of mass that we can't see called dark matter, and now it fits the model perfectly. Surely, there's something else like dark matter going on under the couch that's making the springs arrive faster than expected. At this point, we introduce a concept called dark cat fur into our model. So previously in our simulation, it was taking a little bit too long for the springs to arrive under the couch. So, once we introduce dark cat fur, they should start arriving a little bit more quickly. At first, there's only a minor change, barely noticeable. But as we start adding more zeros to our dark cat fur parameter, then they start arriving faster. Eventually, the springs are magnetically attracted to the couch thanks to the dark cat fur underneath. With 10,000 kilograms of dark cat fur under the couch, suddenly it does in fact take 15 minutes for 6 springs to end up under the couch with a 100% probability. So our experiments have definitively proven that springs do actually always end up under the couch. By introducing dark cat fur into the model, the cat couch equivalent of dark matter, we also can explain why the springs end up so quickly under the couch. These results open the door for lots of new physics research. If there's 10,000 kilograms of dark cat fur under my couch, and just think of how many couches there are in the world, then surely there's a lot of new physics out there waiting to be discovered. Especially given that cats are perfect spheres and celestial bodies are perfect spheres, leads me to believe that surely dark cat fur has a large hand in the celestial motion of the universe. I anticipate great leaps in our understanding of the universe thanks to this research. What's under there, pigeon?